Hello. Today, we're going to introduce you to a machine learning technique anyone can use. But first, a scenario. Imagine you're a chef and you want to predict how busy your restaurant will be. You'll have to consider a lot of things like the weather, the day of the week, the season, holidays. How would you do it? Could you look at all your previous data and calculate this for yourself? Well, I'm here to tell you, you don't have to. Introducing random forest classifiers. But what are random forest classifiers, and how can we use them? First, we have to make sure we're not missing the trees for the forest, specifically the decision tree. To better understand decision trees, let's split our restaurant into 3 outcomes: a busy day, a normal day, and a not busy day. Now, let's take into account just one variable that we're considering, like the weather. Is it bad or good weather? Well, let's say that if the weather's bad, we'll then look at if it's a holiday or not. And if it's not, we can expect it to not be busy. But if it is a holiday, maybe even with the bad weather, we'll have a normal amount of business. Now let's look at the flip side of that variable, good weather. If we have good weather, let's say instead we look at the day of the week. Is it a weekend or a weekday? If it's a weekend and we have good weather, we can expect a lot of customers. But if it's a weekday, we might only see a normal amount of business. As you could guess, a single decision tree isn't very flexible to too much data, especially if, let's say, we had 100 different variables. A single complex tree is not going to be able to cover all possible combinations of data, and will often be wrong. That's why we employ an entire forest to make our decisions. Let's try to predict a rainy 4th of July Saturday. For this, let's consider a small forest of 3 trees, where each tree receives 2 parameters at random from a set of 4. Our first tree considers busyness for a rainy Saturday, which may not be very busy. Our second tree predicts busyness for a Saturday on the 4th of July, which would be very busy. And our third tree predicts busyness for a muggy, rainy summer day, which would not be very busy. These trees vote that a rainy 4th of July weekend will not be a very busy day. While this example isn't perfect, it shows that more trees together can vote on a more comprehensive answer than a single tree alone. To put this in perspective, when you're building a random forest, it's a good idea to start with around 100 trees. To show just how easy it is to build a random forest classifier, we're going to do it in the next 2 minutes. First, we'll prepare our data. For a data type like weather, we can scale it from -1 to 1, whereas -1 would be the worst weather, and 1 would be the best weather. For a different type of variable like weekday, we need a discrete variable, so 0 for Monday all the way up to 6 for Sunday. Finally, for something like holidays, we have to have a bool variable, 1 or true, it is a holiday, and 0, false, it's not a holiday. Lastly, we'll split our results into our 3 categories we had before, 0 for not busy, and 2 for very busy. Finally, the code. We'll be using Python, specifically the Python packages scikit-learn and pandas. First, we'll use pandas to open up our data file. Next, we'll split the data between its input data, our variables, and its output data, our busyness. Next, we'll use the scikit-learn tool train-test-split to split the input and output data into new batches. This is like taking a test. You don't want to give the machine the answer key for the test. You want to make sure that it learned enough to pass it. Next, we'll initialize the random forest classifier from scikit-learn with some max depth, and then fit it using the training data we created earlier. This max depth has a minimum value of 2, but can be increased up until a point where the accuracy stops improving. To determine the accuracy, we'll make a prediction on all of the input data that we held back during the train test split, and then score it using the accuracy score tool from scikit-learn. Since max depth is often small, you can do this by hand. Congratulations, you've just done machine learning. I hope you've learned a new skill and that you can carry this on into whatever career you intend to pursue.